Welcome to lecture number 3 of Advanced Literature Review Techniques using AI tools. Here we will learn about technical standards. A technical standard is a formal, consensus-based document that establishes requirements, specifications, guidelines, or characteristics for products, processes, services, and systems. They are developed through consensus by experts in technical committees and represent agreed-upon best practices. They ensure interoperability, safety, quality, and efficiency across industries and borders. Now, why do standards matter? There are a variety of reasons. Let's look at the top 4. Interoperability. Standards enable products and systems from different manufacturers to work together seamlessly. Without interoperability, technologies would remain siloed and incompatible. Examples include Wi-Fi, USB, and Bluetooth systems. The next one is safety and reliability. Standards establish minimum safety requirements that protect consumers and workers. These include IEC standards for electrical safety and ISO standards for food safety. Third one is economic growth. Standards speed up technology development times and reduce costs. Studies from World Trade Organization show that standards contribute over $1 trillion annually to the global GDP by reducing trade barriers and transaction costs. And the last reason is regulatory compliance. Governments increasingly adopt international standards as the basis for regulations, making standards compliance essential for market access. Now let's look at types of technical standards. Standards are primarily classified using 2 distinct criteria: the generating organization that creates the standard and the technical content of those standards. When categorized by the generating organization, standards fall into 3 major types: de jure standards, de facto standards, and consortia type standards. De jure standards are formal standards. They are formally established by a treaty or government-backed statutory authority. They are developed via recognized, highly regulated national and international standard bodies. ISO standards, DIN standards, and IEC standards are examples. They are developed through open consensus processes with transparent procedures. They have legal or regulatory standing in many jurisdictions. They require formal balloting and periodic review. Typically, they are not free and very expensive to access. De facto standards are adopted organically by widespread market dominance and consumer habit without prior formal authorization. Examples include the PDF format, the QWERTY keyboard, and HTML. They become dominant through widespread market adoption. They often originate from a single company or a small group. These standards emerge mainly because consumers or manufacturers overwhelmingly choose a specific product or format due to its convenience, early arrival, or technological superiority. They are usually free to access initially, but typically gets converted to a de jure standard later on. Consortia standards are rapidly developed by industrial alliances in high-velocity tech sectors like USB, W3C, Bluetooth, Wi-Fi, etc. They are designed to accelerate innovation and ensure interoperability. They are developed through collaborative, multi-stakeholder processes. They are often freely available for implementation and adoption. When categorized by the technical content, standards fall into 6 major types. First, we have fundamental standards. These establish our baseline global language. Without them, international trade and science would collapse. For instance, the ISO IEC 80000 standard governs the exact way we write units and formulas. The ISO 7010 standardizes safety signs. A hazard symbol looks the same in any country, completely bypassing language barriers. Next are test and analysis standards. These dictate the exact recipes for measurement and testing to ensure results are repeatable across the world. A prime example is the ASTM E8, the Universal Protocol for Mechanical Tension Testing of Metals. Moving to product standards. These specify the dimensions, performance, and safety of the actual physical items we buy and use. Locally, a perfect example is the Thai Industrial Standard for domestic LPG gas stoves. This standard ensures that the appliance sitting in the consumer's kitchen will operate safely. Then we look at process standards. These define how things are manufactured or executed. Even if you use good materials, a poor process creates failures. In heavy industry, ISO 3834 regulates welding processes. It guarantees that structural joints, whether in a bridge or a pressure vessel, are welded to a safe, uncompromised standard. Standards also extend into the intangible realm with service standards. These establish criteria for service delivery and customer expectations. For example, the ISO IEC 20000 standard is the global benchmark for IT service management. Finally, we have management system standards. These don't just look at one machine or one service, they look at the entire organization. The gold standard here is the ISO 9001 for quality management. It provides a strategic framework to help a company consistently meet customer demands and continuously improve its entire operation. Let's look at how a single technical standard document is actually built. Almost every international and regional standards follows the exact same structural anatomy. We begin with Section 1. This includes the title page and the front matter. This is the administrative footprint. As you can see on this example ISO standard, it gives us the unique standard number, the full title, publication date, and the special technical committee responsible for this standard. Section 2 is the scope. This section tells you exactly what the standard covers, and just as importantly, what it excludes. For example, in this case, you can clearly see the standard defines safety requirements for rechargeable energy storage systems focused on protecting individuals during vehicle operation. The scope explicitly excludes manufacturing, maintenance, and repair personnel. It also excludes motorcycles and mopeds. Next, we find Section 3, Normative References. This section lists other external standards that are absolutely indispensable for the application of the standard. In this example, it cites these three specific secondary standards, meaning you must comply with those reference documents to claim compliance with this one. Section 4 covers terms and definitions. To avoid legal arguments and technical confusion, industry terms are explicitly defined in this section. For instance, you can see several of the terms that are commonly used in English vocabulary have a strict definition in the standard. Now we arrive at Section 5, Requirements and Specifications. This is the core technical meat of the document. This is where the mandatory elements live. In this section, keep an eye out for the word shall. In standardization language, shall indicates a mandatory requirement that you must fulfill to pass an audit or a certification. Once you have the requirements, you need a way to prove you met them. That brings us to Section 6, Test Methods and Procedures. This clause outlines the exact blueprint for verification. As we scroll through this section on this particular example, you can see it specifies the exact environmental conditions, testing equipment, and mathematical formulas required to verify compliance objectively. Finally, we have Section 7, Annexes. These are appendices divided into two types: normative annexes that give additional mandatory rules, and informative annexes that provide helpful examples, calculation guides, and a bibliography to guide your implementation team. By understanding this universal structure of standards, you can open any technical standard in the world and immediately know exactly where to look for the information you need. Now let's look at the entities that actually facilitate the development of technical standards. Standards Development Organizations, or SDOs. While there are over 800 distinct SDOs operating globally today, we can organize them into three distinct groups based on their jurisdictional reach, regulatory alignment, and industry focus. The first group consists of international standards organizations. These are top-tier, treaty-based or consensus-driven global bodies. Classic example is the ISO, the International Organization for Standardization. ISO is incredibly broad, covering nearly all engineering fields, technologies, and management disciplines, with the exception of electrical and electronic engineering. To handle the electrical sector, we look to the IEC, or the International Electrotechnical Commission. Another major one is the ITU, the International Telecommunication Union, which governs the international telecom infrastructure. Regional and national bodies administer voluntary standardization systems within their borders, often codifying international frameworks into local safety and building laws. In the United States, the national standards body is the American National Standards Institute. In the United Kingdom, it is the BSI. In Germany, it is handled by DIN. And in Thailand, Thai Industrial Standards Institute acts as the central national coordinator. Industry-specific and consortia SDOs bypass heavy bureaucracy to set fast-moving market baselines driven by corporations and tech innovators. Key examples include IEEE, that sets IT and telecom protocols like the Wi-Fi, IETF, that develops core internet networking standards like TCP, IP, HTTP, etc. W3C, that standardizes foundational web layers like HTML and CSS. And the ASTM International, which publishes industrial standards for material and product testing. Now that we understand who develops these standards, how do we actually find, track, and manage them? There are over 500,000 active technical standards in use globally today. To make matters more complex, this ecosystem is constantly evolving. To navigate this massive volume of engineering literature, the industry relies on four distinct types of database platforms. Publisher direct databases. These are the official portals managed directly by the SDOs themselves. Examples include the ISO online browsing platform, the IEEE Explorer for electrical and software documents, the IEC Web Store, and the IETF Data Tracker website. However, if you are running a multidisciplinary engineering project, jumping between 10 different SDO websites is highly inefficient. That brings us to our second type, commercial aggregators. These are powerful cross-functional platforms that license and index data from hundreds of different SDOs simultaneously. Industry standards in this space include the IHS Market, currently under S&P Global, and TechStreet, that is currently associated with Clarivate, and other tools like Acris. For major manufacturing operations, these aggregators serve as a single centralized procurement gateway. The third category consists of government repositories. These databases track national specifications and mandatory compliance documents. Key global examples include the NIST and the ANSI SIBR platform in the United States, the DIN in Germany, and BSI in the United Kingdom. While many industrial standards cost hundreds of dollars per document to fund SDO operations, there are certain fast-moving technology and internet infrastructure domains with repositories that host freely available standards. Prime examples for these are the W3C for web protocols and the OASIS open standards. Alright, so that's all about the basics of technical standards in this lecture. See you in the next lecture. Thank you.